This video is about equilibrium. So the key when the question is 298 kelvins, Gibbs free energy is 1.25 kilojoules per mole, and the question asks us to calculate the equilibrium constant. And the concept of this question is how to calculate Kc using Gibbs free energy. So in our data booklet in the first section, we will find this equation right here. And in this equation, there's the Gibbs free energy, our temperature, as well as our equilibrium constant. So we will be using this equation to solve our question. So our equations state that the Gibbs free energy is equal to negative gas constant. And if we were to look at the second section of our data booklet, we can find the gas constant value right here, which is 8.31 joules per Kelvin per mole. And T is for our temperature, and the units is in kelvins, times ln K, and K is our equilibrium constant. So if we were to go back to our question gives us both the temperature, our T value, and the Gibbs free energy value. So let's write down what we know. So our Gibbs free energy is 1.25 kilojoules per mole, as well as our temperature is 298 kelvins. So we don't need to change our temperature values because it's already in the units that we want. But you can see how our Gibbs free energy is in kilojoules, whereas our gas constant is in joules. So we need to either convert the gas constant to kilojoules or the Gibbs free energy to joules. So in this example, I'm going to convert our Gibbs free energy to joules. So times that by 1000, and we have 1250 joules per mole. And now we can plug in all of our values into our equation. So we would have 1250 equals negative 8.31 times 298 times ln K. And I'm going to simplify this equation, and I would get something like this. Now I want ln K on its own, so I'm going to divide both sides by negative 2476.38, and I would get this number right here equals to ln K. And remember, don't round up this number until the very last step to get the most accurate result. So now I'm going to raise both sides to the power of E to get rid of ln, and I would get K equals to this value. And now that I've reached my final step, I can now simplify this number and round it up to 3 significant figure, and I get K equals to 0.604, and that's my final answer.